Hello, my dear warriors. Welcome, Sandhya. Welcome, Madhumita. Welcome, Epic Queen. Welcome, Deva, Sampath, Navya, Chandana. Welcome, Joel. Welcome, everyone. Hello, Pujita. And this is your NEET English Elite Crash Course, where I'm doing all the important chapters first, high weightage chapters, which will give you easily 150 marks. Okay? So first we'll concentrate in that 120 to 150 marks, and then we'll go to the low weightage chapters. So here we are on friction, the class 11 topic. We have already completed Newton's laws of motion, free body diagram. So there are theory lectures like this one and the previous one, and then there will be a problem solving session with PYQs, NT Abhyas, and my own problems. So all of this in today's class, and this is me, Shreyas, your physics master teacher. Joel, I'll let you know what the solution is. Depends. If you are a JE student, watch the JE lectures. If you are a NEET student, watch the lectures over here. Okay, don't mix it up. And guys, if you want to be my friend, you can be my friend on Instagram. That's where I keep posting all the important updates as well. And yes, you want to ask me something, you can ask me there as well. Thank you so much for joining in. And I'm pretty sure you have subscribed. If you're not, please do that, because that's the only way you will get repeated and constant updates of our classes, or else you will miss the crash course, which is free of cost in English for all the NEET aspirants. Okay, and make sure you show your love, guys, by smashing that like button. All right, so let's begin with the class, and let me tell you guys, there is going to be interesting demonstrations in today's lecture. Okay, so some really cool animations I have got it for you, so stay tuned. We are not only going to see the theory part, concept part, but also apply it in the problems. By the end of the class, you will be so confident of the friction chapter, and that's what you're going to say towards the end also, and you're going to put it up in the comments after the session is over. Sir, friction also done, enjoyed the class. Okay, so very good, guys. Thank you so much for all the hearts, and the hearts are on fire, kids are on fire, the session is on fire. So let's begin, guys. I'm all excited, and you know, nothing more than the happiness that I get from seeing your smileys out here. I'm so glad, Anish. This is like a stress buster for all of you. Hello Tishita, hello Sirat, hello Hariprasad. Nice to see all of you. Prem, you have already seen nurture series. Good. This is a good revision for you for NEET. Okay. So answering a simple question, why is it easier to slide on an icy surface? If you're going to Himalayas or Switzerland or the Alps or some snowy region, some of you are already from Kashmir maybe, or from some hilly region where there is snowfall. So it's easy to slide on a snowy surface or an icy surface, but than on a normal grass. Even when the grass is wet, it is easy, but not on the ground. What is the reason for that? Maybe the answer comes from this particular question also. If you apply oil on the door or anything which rotates or moves, what happens? The friction increases, disappears, decreases, or remains unchanged. Prem Kumar has answered, Deva has answered, Joel has answered. Very good. Sandhya, well, I'm from multiple states, bacha. Each part of our family is from different states. I have roots from Maharashtra, from Tamil Nadu, from Karnataka, from Andhra Pradesh, and you know, or even some people also say some roots probably even in Gujarat. So guys, I'm spread all across. Okay, option C, that's true. That's correcto, amazingo. That's the correct answer, guys. Option C. See, the reason why you can slide very easily on a icy surface is because the surface is very smooth. There are no irregularities. But on grass, ground, irregular surface, you'll get stuck. So that's why it is very difficult. When you apply oil, the friction reduces. When things have to move, they have to bend, there is rubbing. So whenever there is rubbing, there is friction. You put oil, that uneven surfaces become smooth. Easily they can slide over each other, and that's why you will see they will not make noise. They become smooth. It's very easy to open or close, and they will not even rust. So many advantages are there of oiling it. So that's the answer for that. Okay, great. Now what I want to tell you is all about friction, guys. How this friction even originates. If you look at a table surface, or your shoes, road, car tires, or some block or something which is sliding onto something, you might think that it is flat. Or if you look at through naked eye, you will be like, sir, it's almost like smooth only, no. But if you look under the microscope, This is how it looks like. Crazy, right? Look at the number of gaps, look at the number of mountains, look at the number of valleys. It's crazy. So much of unevenness. You will be like shocked looking at this in the microscope. You will be like, sir, can't I just polish it, sir? Can't I just get rid of these mountains and valleys? Make it flat. Make it flat. Fine, try to do it. How will you do it? It's so difficult. Even if you try to rub it using something, that surface will get damaged. That surface will also have some unevenness. So it's very difficult to do that. You do not have all the time in the world. Okay, under the microscope, this mountain I'm going to remove. Okay, this mountain removed. Okay, this valley I'm going to remove. How much will you do? It's not possible, guys. So it's you cannot reduce the roughness beyond a certain limit. So all the surfaces around you, there is some kind of interlocking. These gaps, these pointy things, they get interlocked, they get stuck, and that's why you will see there is resistance to motion. And that resistance to motion between the two surfaces is basically called as friction. Yeah, your tongue also, guys, if you see under the microscope, you will be shocked. And you guys are bio students, soon I'm pretty sure you'll be seeing so many different things under the, all the cells and tissues under the microscope in the days to come, maybe even in biology practicals or in MBBS. So even your tooth, you might think your tooth is smooth, right? Look at the tooth under the microscope. You will see, oh my God, it's crazy. So nothing is smooth. Remember that. Whenever you try to move things relative to each other, that roughness gives you that resistance. That resistance between the surfaces is called as friction. This friction always opposes the motion or the tendency of the motion. Now, what do I mean by that? What do I mean by it opposes the motion or tendency of the motion? See, the problem of students when they learn physics is they by heart, friction opposes the motion or the tendency of the motion. Okay, and friction is the force of the resistance when two surfaces slide with respect to each other. That force is called as the frictional force. Frictional force is expressed in Newton. Dimension is m1 L raised to 1 t raised to minus 2. Sir, I know everything about friction. Sir, see, such a nice paragraph I wrote. What does it mean? Understand. So that is the mistake what you do when you read through NCERT. Okay, so understand what it means. Even the simplest of the things can have so many hidden meanings. See, imagine you are in the classroom, guys. Teacher is teaching. A good teacher like me, I hope I'm a good teacher, is teaching. You are a student. Suddenly, something is happening on the playground, some event is happening, kids are playing. You start looking. That is your motion. You slowly go towards the window. Slowly go towards the window. Start looking. Oh, look at those kids. So nicely they are playing. And then you are cheering them up also. Oh, very good, very good. Oh, hit the goal there. Yeah, hit the shot there. Teacher will be like, hold your ear. Come. Sit in your bench. है ना? Teacher will pull you back. Resistance. Okay? Pull you back. Your motion is there towards the playground. What is happening? Teacher will pull your ear and bring you back. Correct? Yes or no? Very good. Second thing, teacher is teaching. You know teacher is strict. If you go there, teacher will hold your ear and bring you back. So you're just looking at the teacher like this. Teacher is teaching, blah, 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 teacher is teaching. In your mind, something else only. What is that score? What is happening there? What is there in food? Jalebi, gulab jamun, idli, dosa, everything is running in your head. Teacher thinks you are looking at that board. But little do they know that everything else is there in your head. All the other things are there in your head. You are thinking about everything in the world. But a smart teacher like me, looking at the student, hey, listen, what are you thinking? You are looking at the board, but you are not thinking about the topic. Come back, start thinking about the topic. That is your tendency. You have not actually moved. You have not actually moved. It is your tendency. Same way, even a body might look to be at rest. Imagine this is at rest. You will be like, Papa, no friction, sir. But maybe it wants to move. Maybe it wants to fall down there. Maybe it wants to slide. It wants, na? It has not done, but it wants, right? So that want will be opposed. That is called as opposing the tendency of the motion. Sometimes it might be actually moving. That time the friction will actually be acting in the opposite direction. Understood? Everybody with me on this? Deva, looks like there was a practical of whatever I told you in today's chemistry class. Biology class also says Rose. Okay. Thank you, Deva. Physically present, mentally absent. Very true. So that is the meaning of friction opposes the motion or the tendency of the motion. Now there are two types of friction. Very good. Everything is clear. Amazing. Go. I hope you have smashed the like buttons down there. If you have forgotten, just reminding you. Need to remind all of you. Smash the like button, smash the subscribe button. Very good. There are two types of friction. One is static, one is actual kinetic. Why are there two types? Because there are two kinds of things. One is actual motion, one is tendency of motion. So the two types of friction are, number one, static friction. One is basically static friction. The second one, dynamic, or just simply put, kinetic friction. This is just called kinetic friction. Okay, very good. Now what happens in static friction and kinetic friction? Let me just show this to you. Imagine that there is a block, surface, whatever. This is your surface on which the block can move. Same block, same surface. Now the moment I use the word kinetic, it means it is actually moving. So there is motion. There is actual motion in this direction. But in static, there is tendency to move. This is the direction of the tendency of the motion. It's not actually moving, it is at rest. Keep this in mind. So these two surfaces are not really moving. This is basically going to be at rest. This is actually in motion. What you will see in either of the cases, the friction will oppose the tendency. Generally the symbol for friction is small f, not capital F. Here also the friction will act in this direction. Because this friction is acting for static surface, it is Fs. Because this is acting when the surfaces are sliding with respect to each other, that means kinetic in nature. So you use the subscript K. Fk, Fs. S for static, K for dynamic or kinetic friction. Very good. Rolling friction, it will come in a separate chapter, but still I will explain a little bit part of it in this lecture as well today. Now, once you understand how static friction and kinetic friction acts, remember that these two frictional forces have some common properties also. Although I am going to give you the differences, there are some common properties. Let me put the common properties on the next slide. The common properties are, number one, the frictional forces are independent of the area. Keep this in mind. They both are independent. Of the contact area. So it really does not matter so much. It nearly is independent. Hardly any changes happen. So you can treat it as independent of contact area. That's another one thing. Number two, these frictional forces are evil forces in most of the cases. Basically what they do is they suck out the energy. Just try this if you don't believe me. Rub your two hands. Rub your hands. What happens? Do you feel some temperature going down or up? Come on, put it up in the chat box. Just rub your hands. Don't drop your phone somewhere. Just keep the phone gently or laptop gently. Yeah, do you see something? I can hear some sound. I can feel the heat. Yes, there is temperature increasing. But the temperature is increasing, sound is there. That means the energy is coming out. From where? My motional energy. Who is sucking away my motional energy? Who is sucking away the kinetic energy of the hands? Friction. Friction takes away that energy and converts it into sound, heat, light, whatever. So energy loss. So friction causes energy loss in the form of generally heat, sound, whatever you want to call it, and so many other forms. So there is definitely some energy loss. So mechanical energy is not at all conserved. Whenever you see that chapter or if you have seen it, you know it. Okay, all these are important things regarding friction. Okay, more common points, I'll keep adding it as we proceed, but let's come back to this slide where we are talking about differences. Now these frictions also behave a little bit differently. I have to put it over here. This friction is actually a self-adjusting force. It's a self-adjusting force. Whereas kinetic friction, it does not self-adjusting, it is a constant force. Always stays constant in nature. Now what do I mean by that? Best thing to do is show you a demo. Okay, that's me teaching you guys. So hardworking teacher. Okay, so coming back over here, you can see this box, you can see this Pandu. I can get many people out here. Look at this. Oh my god, look at the way he sits. What happens if I put this girl? Oh my god, crazy, right? And what if I put that dustbin? Oops. Oh my god, where did that box go? Okay, let's put this guy back, let's put this girl back, let's put this dustbin back. Let me get this box over here. Great, awesome. So you can see I can apply some force. You can see I can change the friction. I can also see the speed. I can see the net force. Right now, net force is 0. Okay, so nothing else. Values, I don't think I need it. But I just put the speed. Speed is also 0. Great. Now, here's what I'm going to do. Here's what I'm going to do. I'm going to apply some force. How much force is he applying? 1 Newton. He's applying 1 Newton force, guys. Everyone with me? Let me see if I can get those forces shown somewhere. Yeah. So can you see applied force is 1 Newton? Frictional force is 1 Newton. Why? Newton's first law. If the net force is 0, the body maintains its state of rest or motion. Body is at rest. Yes. Net force should be 0. Normal balanced by mg. So my applied force, who will balance? Friction. Which friction will this be? Static. Why? Because it is not moving. Correct? I'll apply more force. How much force am I applying? How much force am I applying? 4 Newton. Is it moving? No. So how much frictional force will be acting? 4 Newton. Which way? Opposite. When I applied 1 Newton, friction became 1. When I applied 2 Newton, friction became 2. When I applied 3, it became 3. 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. This is crazy. Friction is adjusting itself. So nice. So nice, no? Such a nice guy. Adjusting nature. How much ever you want, that much it gives. How much ever it wants, that much it gives. Hai na? Great. This is like a game only, but you will enjoy and learn a lot through this game. I'll be like, sir, if I apply more force, friction will also keep increasing. This is so good. It's like you go to your mom and dad today and say, listen, I want to buy a compass box, pencil box, please give me 100 rupees. Mom and like, okay, take. Adjust and give you. Tomorrow you go and ask, listen, I want to buy a new school bag, please give me some 700 rupees. Okay, fine, take. Next day you go and say, listen, it's my birthday, I just want to treat my friends, please give me 2000 rupees. Okay, fine, take. Next day you go and say, listen, I want a new bicycle, it is 30,000 rupees. They'll remove the slipper and thup, 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 they will hit you. Correct? Limit. That's it. Enough. Done. Gone. Hai na? You will get nice slippers, beatings. Limit is done. Enough is enough. Yes or no, guys? Yes or no? So, I think there is a limit to this. What is the limit to that? I don't know. Let's find it out. Let me apply big force and see what the limit is. 50 Newton, it didn't move. 50 Newton more, 100 Newton still didn't move. Wow, it's adjusting. Good. More 50 Newton. Oh, look at that. It has started moving, guys. Look at that. It has started moving, guys. Limit is crossed. Limit is crossed. Let me get back this situation. Let me get back. Oh. This guy stopped. Please stop. I think he'll magically come here. No? He's not coming? Okay. 100 Newton. I'll just try to find what is the limiting force. 110 still not moving, okay? 111 not moving, 112 not moving, 114 not moving, 15, 16, 17, 18, 19, 20 not moving, 22 not moving, 23, 24, 25. Just at 125 Newton it started moving. So there is a limit of the friction. That is called as the limiting frictional force or the maximum static frictional force. That's the maximum force of static friction that it can give. Maximum static force. Everybody agrees? Okay. Now do you see the frictional force has reduced? I don't know whether you can see this number over here. Okay, maybe I'll just maybe I can just put it to 0 or something. Yeah, I think you can see this. This is 94 Newton and it stopped, gone. That 94 Newton is much less, and that 94 Newton was acting when it was already in motion. What kind of friction that must be? I'll show this to you again. Look at this, 200 Newton force applied. Okay, you can see now the moment it has gone into motion, the kinetic frictional force will act. Now look at this, just remove this. Do you see kinetic frictional force is 94 Newton? You will be like, sir, to make it move, I needed 125 Newtons, 126 Newtons. But once it is already in motion, I need less force, sir. Why? Why do I need less force? Reason is, once it is already in motion, all those gaps, those multiple peaks and valleys, they are already going to be in sliding motion. They are not going to get time to interlock themselves. Because they are already into motion, they have inertia, because they have momentum, you will see they'll just go over each other, there will hardly be any resistance. But if you stop them, they will get nicely interlocked. To start the motion is difficult. So starting the motion is more difficult than sustaining the motion. Agree or disagree? Agree or disagree? To start something is more difficult than to keep it in motion. And this is true in life also. To start your studies is always very difficult. But once you get into that mood, first 5 minutes are over, you don't know how it goes and you go with the flow. Yes or no, guys? So that's how it works. So I'm just going to put it over here. Starting the motion is more difficult. I'm just going to put it over here. Starting motion is more difficult. And over here, I'm just going to put basically to maintain the motion. Is easier. That's another thing which you should know. Now the maximum static frictional force which can act on this body, which is the limiting static friction, is given by the symbol Fs max, and the value of that is given by mu subscript s, because it is related to static, into n. If you are wondering what the hell is this n, this is nothing but the normal force acting between the surfaces. This is the maximum static frictional force which can act on the body. This mu s is nothing but called as the coefficient of your static friction. This is just a number. Given to you like 0.7, 0.2, 0.38, 0.95, etc. This number, which is the coefficient into the normal force, gives you the maximum limit till which static friction can increase. Yes, MB, this lecture plus question solving lecture and PYQs and your own practice material is needed. Obviously, your mock test, your own practice material is going to be needed, like PYQs, etc. Without that, don't expect to qualify NEET. Okay, not qualify, to clear NEET with good marks. Okay, but in case of kinetic friction, like I said, it is a constant force. So that kinetic friction just happens to be coefficient of kinetic friction multiplied by the normal force. Again, this is the normal force between the surfaces. This mu k is just called as the coefficient of kinetic friction. Again, it's a number. So what is this mu in general? If you talk about it, what the hell is this mu? Mu is just called as the coefficient of friction. It could be static or kinetic, either of them. If the value of mu is more, that means the surface is more rough. It is more rough. It's very difficult to slide things. If mu is 0, then it means it is a perfectly smooth surface. You hardly encounter any resistance. Just like in ice, coefficient of friction will be 0.0 something. Very, very small value. Or if it is 0, it is perfectly smooth. That's what it is. Okay? I hope this is clear, my dear students. So mu is higher, it is rougher. Mu is 0, it is very, very smooth. Now usually you will see the value of mu s will be more than the value of mu k. Why is this the case? The answer lies over here. To start is difficult, to sustain or maintain is easier. Hence, kinetic friction coefficient is less than static friction coefficient. That's why you will see this to be true. This is simple. Okay, just based on that pointer mentioned on the previous slide. Okay, now why does that depend on the normal? You can see that over here, bacha. Imagine over here, this box is kept on the surface. If you add more weight, what will happen? There will be more interlocking. If it is light, there will be less interlocking. The more the normal force from the top, you will see that there will be more interlocking. So it is more difficult. It is more difficult for it to slide. Even this diagram probably will give you better idea. This one over here. See this? If there is more pressure, more normal, the interlocking will be higher, and that's why the frictional forces will also increase. So that's why the friction depends between the normal between these two surfaces. Is that clear? Very good question, Sandhya. Very good, very good. Okay, so let us go ahead. Where are we? Yes, over here. Excellent. Moving ahead to the next few pointers between static and kinetic friction. Usually the value of mu will be like 0.6, 0.2, 0.4, etc. Something like that. Okay, so let's see if I can show you one simple question and simple example just so that you get an idea. Imagine that there is a mass over here. That mass is, let's say, for example, 20 kg, just for the sake of it. It's on a surface. That surface has a value of mu s, example 0.5, and mu k equals to 0.4. This is the value of mu s and mu k given. From this, I can find everything about the frictional forces. For example, the maximum value of the static frictional force, which is mu s into n, will be, well, I don't know the value of n right now, so maybe I should draw the free body diagram. Normal will be upwards, the weight will be downwards, which will be 20 g. So normal force will be 20 into g, which is nothing but 200 newtons. 200 newton. So basically the Fs max will be mu s, which is 0.5 into 200. One of the zeros you can swallow it inside, so it will become 5 into 20, which is nothing but 100 newtons. Everybody with me? Everybody with me on this? Is that clear and understood? Great. Okay. Now another thing that we can find out is the value of Fk. And Fk will be nothing but mu k into n. Mu k is nothing but 0.4. Normal force is 200. I can swallow one zero, so it will become 4 into 20. So that means this will become 80 Newton. So if somebody asks you how much minimum force you need to start the motion, the answer will be 100 Newton. If you see that it is already in motion, then the force of friction will be 80 Newton. So this is for kinetic, this is for static. So maximum can be 100, it can be even 20, 30, 40, 50, 60 Newton. This is the maximum limit of the static friction. Great, great. So how 10, Rakesh? This is the value of G, na? 20 G. What is the value of G? It is 10, right? What is the value of G? G is 10, right? Usually we'll take it as 10, unless specified otherwise. 9.8. I don't like that value, 9.8. Okay, so let's start with some questions. I've kept some animations. Look at this funny animation. Static friction. Papa, this guy is trying to push. Friction is just opposing. It's just adjusting. This guy is actually sliding it. You can see the friction constantly is acting on that body. So that's kinetic friction for you. Now, I have kept all the theory slides in written form also, just in case you want to watch it later on. All the things, coefficient of friction. Now, let me just give you a small thing, small idea about rolling friction. You would have seen that the invention of the wheel was a big invention in the history of mankind. It changed things. Many people in those days, like long time back, people used to slide things, but the moment they invented the wheel, they saw that when you roll things, it is much easier. So that is called as rolling friction. That rolling friction is something which you study in rotational mechanics or rigid body mechanics. There you will see how when things are rolling, the friction which acts at the point of contact usually is much lesser than either kinetic or the static friction as well. So that's a brilliant thing about rolling the objects. So you will see the friction at the point of contact is very low. That makes the things, their motion easier. Here is the simple question coming up on your screen. The limiting value of static friction between two surfaces in contact is proportional to the normal force between them, independent of the area of contact, depends on the nature of the surface, or all of the above. Always shake. Hello Anil Prasad, welcome bacha, thank you, cute videos. High weightage, medium weightage, low weightage. Yes, that's the flow of my lectures. Exactly. Shake and cute videos, thank you for pointing it out. So yeah, that's the way it's going to go. So all of you are saying D, some of you are saying B. Well, decide guys, is it D right? Perfect. Okay, sure. Lock kiya jaye. That's it. That's the correct answer. All of the above. The limiting value, that means the maximum value, the limit till which frictional force can increase, is given by mu s into n. So definitely Fs max is going to be proportional to n. Independent of the area, I just told you. Yes, it is independent of the area. That is true. Depends on the nature. You can see this mu is going to be dependent on the nature of the surface, because you will see wood and wood will have different mu, steel and aluminum will have different mu, rubber on the road will have different mu. So it depends on what is the nature of the surface. So that is what mu is dependent on. So hence the answer will be all of the above. Which of the following is incorrect? Which of the following is incorrect? Okay, come on guys. Joyce Zot, nice to see you bacha from Mizoram. Lot of students from Mizoram, Nagaland, Assam. I mean, I get the channel analytics from where you guys keep watching our lectures. Lot of students from especially South, Bombay, Delhi, even from West Bengal and Northeast, and even from Dubai, UAE. So many students. I'm so glad that this English channel is helping all these students out here, and that was the whole intention of starting this channel. So welcome aboard guys. So Madhumita saying option D. What about others? Hello Santosh. Come on bacha log, start answering the questions out here. Very easy. Which of the following is incorrect? Incorrect. Pujita saying D. Prem saying D. GV saying B. Aisha saying D. Okay. Sampath, cute videos, Sandhya, GV, everybody saying D, Niranjan, Maha, Nandini, everyone, Deva saying D option. Very good. Coefficient of sliding friction has dimensions of length is wrong, guys. See, frictional force opposes relative motion. That is true. Friction opposes. If the motion is here, friction will be opposite. Correct. This is true. Limiting value is proportional to the normal reaction. This is also correct. Fs max is directly proportional to normal. This one, if the motion is here, you will see the frictional force will be this side. Correct. Rolling friction is smaller than sliding friction. I just told you. Okay, if you have an object, if you have to move it like this, versus if you have rollers below it, this one, if you have to move it like this one will be easier. So this tells you rolling friction is easier to overcome as compared to the sliding friction. The last one, coefficient of friction has a dimension of length. That is wrong, guys. Friction is mu into n. So mu will be friction by n. Both force and normal, both these things are nothing but forces. This is also force, this is also force. So mu, actually speaking, will have the dimensions of just nothing. It is completely dimensionless. So saying that it has the dimension of length is definitely a wrong statement. Okay, so that's the answer, guys. Here's the next question up on your screen. No dimension. Very good, Sandhya. Very good, very good. A body is projected along a rough horizontal surface with speed 6. Body comes to rest after traveling 9 meters. Then the coefficient of sliding friction is. Very good, Prem. Very good, Madhumita. Very good. Answering the questions perfectly. Even giving the reasons is very important. So how much is the coefficient of friction. I think you will need two concepts here because it is decelerating. Maybe you might need equations of kinematics over here to solve the question. Let's see. So let's just draw the diagram. This is your mass. It's already moving with certain speed with 6 meters per second. Okay. It finally stops over here. This is basically at rest. How much distance does it travel? It travels 9 meters, I believe. Yes, it travels 9 meters. Okay, so basically it has decelerated during this motion. All right. So why does it decelerate? We can reason it out. If you draw the free body diagram, if at any given point the velocity was this way, the weight was like this, mg, there was normal force acting upwards. Because the motion was this way, the friction force will be kinetic and it will oppose the motion. The motion will be towards your right during this motion from here to here till it comes to rest. This friction retards the body till it comes to rest. So using Newton's laws of motion, the kinetic friction is mass into acceleration. Kinetic friction is mu k into normal, which is equal to mass into acceleration. The normal force on this body will be numerically equal to mg, which is the weight, correct? Because upward and downward force cancel each other. This process of showing the forces is called FBD, free body diagram. I've explained that to you in the previous lecture. So make sure, in case you have missed it, watch that class, in case you are not so well to do with FBDs and Newton's laws. So this will be nothing but mu k into mg is equal to m into a. M and m gets cancelled. So acceleration will be coefficient of kinetic friction into acceleration due to gravity. Okay, this is separate, but this will not give me the answer because I do not know the acceleration. So here is what I'm going to do, my warriors. Because I know it is stopping, I'll use kinematic equations. The best equation to use is v square is u square because it is decelerating, so minus 2as. Final speed is 0. Initial speed is 6 minus 2 into acceleration is mu kg, mu k into g. Displacement is basically 9 meters. Bring this entire setup over here. So this will become 2 mu k into g, okay, into 9. So this is not dot, into 9 is equal to 6 square, which is nothing but 36. So the value of mu k will be 36. Will be nothing but 36 divided by 9 2s are 18. 18 into g. Now 36 by 18 is 2, 2 by g, that is 2 by 10, which is 0.2. So the value of mu, coefficient of friction, kinetic friction, is 0.2. Where do we have it? Option D. That's it. Most of you have given it. Very nice. No, Sandhya, it was not 0.4. I think you made a calculation mistake. Very good, Tarika. Very good, GV. Vijay, Nandini. Excellent, Pujita, Navya, Aisha, Sampath, Prem, Pujita. Very good, very good, very good. Excellent, my warriors. Cool. Are you getting some hang of coefficient of friction, kinetic friction, static friction? Little bit at least. Let's move on now to the graphical part. Great. Excellent. Now, the graph is also important. How does friction change? What you saw was in that simulation or in that animation which I showed you. When you apply the force, the friction also increases. You apply more force, the friction increases till you reach a certain limit. Till you reach a certain limit where the static friction is overcome, and you will see the friction turns into kinetic. So friction keeps increasing, and then it suddenly drops. So over here, let me just bring it back. If I show the graph also looks very similar over here. You can see it is static in nature. It is basically static in nature. You can see it is self-adjusting initially. It is self-adjusting initially till it reaches the limiting value, which is obviously Fs max, and then the fall is sudden. It's not so gradual. Here it looks like it is very gradual. Actually, it is very much sudden. It's not the exact way it should look like. So it basically falls like this, and you will see it enters into the kinetic zone. You can see it enters into the kinetic zone, and this kinetic zone, you will see the frictional force is not adjusting. It is constant in nature. No matter what you do, friction remains the same. Correcto? Understood? So maybe I can show you an example, numerical example based on the graph. Very common this graph is. I mean, it should be there in your books, in your notes. Okay, so you can see over here there is a block. Over here there is a block, and I'm going to apply some force onto it. I'm going to apply some force onto it. Okay, and this is called as capital F, and the frictional force is obviously going to oppose it. I'm going to label it as small f. So small f, friction, will be on the y-axis. My applied force will be over here. So this is my applied force. This is my applied force. This is nothing but my frictional force. My frictional force. So imagine I already tell you the value of Fs max. The value of Fs max is 20 Newton, and the value of Fk is, let's say, 18 Newton. Now I create a small table over here and see what exactly is happening. I see what exactly is happening. Okay, so this is my applied force, this is my frictional force, and then I comment on it whether it moves or it doesn't move. So let's start with it. Imagine I apply 0 force. That means I do not push it. Friction will be 0. If I apply 2 Newton, friction will also be 2 Newton. Correct? And if I apply 10 Newton, friction will also be 10 Newton. I take it to 18 Newton, friction will also be 18 Newton. It is adjusting because the maximum limit is 20. If I take it till 20, it will still remain 20. If I bring it down now to 12 Newton, it will come down to 12. If I again make it 20, it will again go to 20. Now if I make this 22 Newton, that's it, it will start moving. All till here, it was basically at rest. Rest, 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 rest. It was all at rest throughout this. The moment I apply more than 20 Newton, you will see the friction will enter into the kinetic zone. It will then become 18. If I increase the force to, let's say, 25 Newton, it will still remain 18. If I make it 50 Newton also, it will remain 18. So after this, you will see it is basically entered into the motion. It is no longer at rest. Everybody understood this simple table, what I have drawn? So if I show it on the graph, maybe it will look like this. From 0 to 20, it did not change. From 0 to 20, it did not change. So basically, this will be 20 Newtons. And after 20 Newton, it has dropped. It has dropped. And then it stayed constant till whatever forces you applied, it stayed constant at 18 Newton. So this is how the graph of friction will look like. Great. Awesomeness. I have a simple question for all of you. Okay, this is a beautiful question. Let's see how many of you are thinking out of the box. Do you see the difference between these two? How much is the difference? 22 minus 18, 4 Newton. Check the difference between these two. 25 minus 18, guys. Isn't it there? It is nothing but 7 Newton. What do you think these differences are exactly trying to do? 4, 7, whatever. What do you think it is trying to do? I'm applying 22. Friction is 18. 4 Newtons is extra. Oh, it is trying to accelerate it. It is trying to accelerate it. Did you see that? Yes. So this 4 Newton will basically cause acceleration. So this will be mass into acceleration. This will be also mass into acceleration. Understood? So the difference of the forces creates acceleration or deceleration, whatever it is, whichever is more, accordingly. So basically it will change the speed or the velocity of the particle or the block. So that's what you should understand. Great. Let's see if you can solve this question. No, you don't have to solve all the questions, bacha. Just solve the NEET level questions. That's it. And how much ever you can solve that. See, if you try to solve all the questions, maybe you'll just complete 10 chapters out of 30 chapters. But instead, if you do 50% of each chapter, maybe you will cover all the chapters and you will probably have solved most of the variety of the questions. So that is better than just doing 5 or 6 chapters, completely. Because then you might have gained confidence, but then you'll not get marks. That's the problem. Okay. A force of 20 Newton is exerted on the snack box of 5 kg still on the floor. Coefficient of friction is given. Calculate the friction and its nature. Calculate the friction and its nature. Okay, let's try to understand the question over here. So we have a block or a box, whatever, on a surface, and it is basically 5 kg. So if I show the forces acting on it, there will be 5g force over here, there will be normal on the top, which will be 5 into G, which is 5 into 10, which is basically 50 newtons. So 50 Newton is the normal force. So you are applying a force of how much? 20 Newton over here. So obviously friction will oppose it this way. So the question is, what is the friction and its nature, meaning static, kinetic, etc. Okay, let's do one simple calculation. Let's try to find out what is the value of Fs max. What is the value of Fs max? Is it even moving or not? Let's find it out. Friction coefficient is 0.3. So it is mu into n. Mu is basically 0.3. Normal force is nothing but 50. So I can just bring it like this, 3 into 5. The decimal I swallow it with this 10. 3 5s are nothing but 15 Newton. Oh, look at this. Limiting friction is 15. Applied force is 20. It is more. It is more. That means if this is basically less than the applied force, it just means one simple thing. The friction is kinetic in nature. That's all. That's all. That implies the friction is kinetic in nature, and the value of that friction is again mu into n. If you try to solve it exact same way, you will get this as 15 Newton. Same thing, 0.3 into 50 will give you 15 Newton. So that's the answer, guys. Kinetic, and it is 15 Newton. Understood? Hello Mahima, join in bacha. Even if you have joined in today, I'm pretty sure you can check out the playlist. I'm pretty sure you know how to use YouTube and all that. Please check out the past live sessions. The playlist is also there. Make sure you are staying up to date. Entire modern physics is done, guys. I have posted the link of the playlist on the community page and also on the Telegram channel. Make sure you're a part of the Telegram channel. Okay? Great. Rakesh, it is kinetic because my applied force. How much is my applied force, bacha? How much is my applied force? The applied force was 20 Newton, na? I'm applying 20 Newton, but the limit is 15. Limit is 15. I'm applying more than it can sustain. So obviously it will slide. And once it slides, what kind of friction will be there? Kinetic. Got it? Rakesh and others? Hello Priya, welcome bachalo. Let's join and see the next topic, and that is basically angle of repose. Okay, what is this angle of repose? Has it ever happened to you? I don't know. I have seen some people, in this kind of a pickle or situation. Like there is a slide. When you are young kids, you would have always gone on a slide. You sit on the slide, but you don't slide down. Has it happened? Has it ever happened? Thank you, Deva, so much. It means a lot when you say such things. You guys doing it for me. Thank you so much. I am doing this for you. Yeah? Okay. Have you done this? Have you done this where you take the exam pad or your book, you place a rubber or a sharpener, and slowly you are getting bored. Teacher is teaching something, blah, blah, blah. Okay, you're sitting at the back bench or front bench also, I don't know. And you are just slowly increasing the angle till the pencil or book or whatever, block or rubber or sharpener starts to slide. You slowly increase the angle, zoop, it starts sliding. Have you tried this? So that concept is basically angle of repose. Yeah, exactly. So, my dear students, what is angle of repose? It is the minimum angle of inclination of the plane after which the two surfaces begin to slide. Because when you increase the angle, gravity will start pulling it down, a component of it. So as you increase the angle, there is more gravitational pull, and friction can only sustain till some amount. So then it gives up and then they begin to slide. So that angle at which it just begins to slide or till which it can sustain is called as the angle of repose. Great. Felt that? Yes, that's what you should get. You should feel. See, you might have seen angle of repose in school or your coaching, but if you have never felt it, then there is no point, guys. And that's why I am here, so that you can feel physics. That's the whole idea of my teaching. Now, let me just show the box. Maybe this inclined plane, the angle of inclination alpha, that's the angle of repose. Usually, I'm going to use the symbol alpha, my dear students. The forces acting on the mass. I've already shown these kind of FVDs in the previous lecture. Please watch it, guys. But still, I'll just show you. Mg will have two components. Let's see how many of you are able to quickly think and tell me which is this component. Is this Mg cos or is this Mg sin, Mg tan, Mg sec, Mg cosec, mg cot, what is it? This component down the inclined plane. mg cos, sin, tan, cot, sec, cosec, sin. Very good, Priya. First one to answer, Vijay. Very good, Anish, Sandhya, Madhumita. Very good. So that is mg sin alpha component. This component, obviously the other one will be mg cos alpha component. Obviously there will be a normal force like this. Where do you think friction will act? Down or up the plane? Think, what is the tendency to move? You will get the answer. Because of the gravity, it wants to come down. Friction, evil guy, it will always oppose. So obviously it will act up the incline. Up the incline. This is static in nature. But when it is on the verge of sliding, just increase the angle little bit more, gone. Doop, it will start sliding. So this friction is not any ordinary friction. This is the maximum frictional force. It's on the limit. It's on the verge of sliding. Okay. This is basically the situation shown, which is on the verge of sliding. Anything more angle wise, it will start sliding. So now you can see in the y direction, n will be equal to mg cos alpha, and along the inclined plane, I can say mg sin alpha will be fs max. But wait a minute, fs max is mu s into n, right? And n is nothing but mg's cos alpha, right? So here I had mg sin alpha. You can clearly see what is getting cancelled. mg got cancelled. So bring cos below. So it will become sin alpha by cos alpha will be nothing but mu s. So mu s value, sin by cos is nothing but, my dear students, what is it? Tan alpha. So mu s is basically tan alpha. This is how you can find the angle of repose. Or if angle of repose is given, what can you find? Coefficient of friction. One way or the other. That's it. Tan alpha, should remember this. It's independent of the mass. It's independent of gravitational acceleration. It's only dependent on the nature of the surface. Cool? Let's do some questions on this. Okay, I put the printed material also. Tan alpha is mu. If a body begins to slide at 37 degrees, slowly increase, 37 degrees, zoop, it starts sliding. After that, the coefficient of friction for that surface with the body is 0.5, 0.75, 0.33, 0.86. Why can't I cancel alpha? Very good, Srikant. If that is the case, na bacha, where did it go? Okay, this na, why can't I cancel alpha? See, I think it is a very genuine doubt, unless you're just summa asking it. See, my dear student, when I say sine of alpha and when I say cos of alpha, lot of students ask me, it's okay to ask this doubt, why can't I cancel alpha and alpha? If that's the case, why can't I cancel this s and cos s? I could have done that also, no? So it should be in by co. The reason why I can't cancel alpha is this is sine of alpha. It's a function. It's a function. This is not s into I into n into alpha. No, it is not that. This is not c into o into s into alpha. No, it is not multiplication of numbers. It is sine of alpha. It's a function. Understand that. You put in alpha, you get sine of alpha. You put in another value of alpha, you get another sine. Okay, that's what it is. If that is the situation, then maybe I can even do this dy by dx. It's not d into y. It's not d into x. Then I can also cancel this d and d. So this will be y by x. It's not that. Understand, it is d of y, derivative of y, change of y. So it's just like saying, you know, delta of y and delta of x. I can't cancel this delta and this delta. This represents change of the y. It's a function. Think of it. It's an operator. You cannot cancel that operator. Okay? I hope that is clear. No, it is okay. Got it? So I am open for the most basic of the elementary doubt, guys. It's okay. As long as you learn. So if a body just begins to slide, guys, what is the answer? Many of you are saying B option. Very good. Proud of all of you guys. Here is the answer for this. I will just use this formula. The coefficient of static friction is basically tan of alpha. So this is nothing but tan of 37. Oh, what is tan of 37? You guys forgot? Come on, it is 3 by 4. It is 3 by 4. So 3 by 4 is quarter, 3 quarters rather. So it is 0.75. 3 by 4 is 0.75. No, it's not 0.5, it's 0.75. I don't know what happened to that option C. Suddenly it became gayab. It was not 0.33 anyways. Answer is 0.75. Cool. Moving on to another question. Sometimes you might have seen students fighting in the classroom, and then what happened is one day Pandu fought with Laddu. So this is Pandu, guys. This is Pandu. This is Pandu. Pandu, what he did is he fought with Laddu. This is Laddu. Okay, so this is Pandu and this is Laddu. And then what he did is he held him against the wall like this. He's holding him like this. Why did you eat food from my tiffin box? Where did you hide my homework? Why did you throw water on me? He's holding him. So this is Pandu and Laddu fighting. I caught them. This problem is also like this only. Now, question is, how much force Pandu must apply so that Laddu does not slide down? Just imagine, guys, what a flop show it will be. Pandu is holding him, but he does not apply too much force. Laddu slides down and he goes from below and he runs away. It will be one big flop show, no? Yes or no, guys? Hello, Gopika. So you have to apply some minimum force. That's what the question says. So try to relate the problems in real life. Make a funny situation. Make the worst of the worst or best of the best situation. Just try to do this. You will get an idea. You will get the feel of the problem. If they ask in exam who is Pandu and Laddu, it will be a 20-30 marks question. Nobody will get it right. 100% sure. So here the crux of the problem is to understand when you pressurize him, there will be a normal force. That normal force will also help in the friction, and that friction will help him from sliding down. So let's try to draw the free body diagram of this block. If you apply a force here, by the way, there is weight which is going to act down, which is mg. I think a normal force will come from this side, this way, and friction will prevent this body from sliding down. So hence a frictional force this way, because you are applying as less force as possible. It is on the verge of sliding. So this friction is not any ordinary friction. It is Fs max friction. It is Fs max friction. Is everybody with me? Great. So over here, can I say that my force is balancing normal? My force is balancing normal in x direction. In a y direction, can I say my mg force down is a balancing Fs max? Fs max. What is Fs max? Mu s into n. What is n, guys? N is nothing but F. So it will be mg is equal to mu s F. So F will be mg by the coefficient of static friction. That's it. That is my answer. Then done. If I know mass of Laddu, if I know g, which is approximately 10, and if I know mu, that's it. I know how much minimum force I should hold him against the wall so that he does not slide down, and it will be a flop show otherwise. Great. Perfecto, guys. Amazing. Very good. Let's move to another question. This is also a brilliant question. I'm showing you how to apply the concept of friction in questions. Because next session, what is it going to be? Problem solving. On what? Pulleys, constraints, pseudo force, friction, all these graphs, Newton's laws, equation, FVD. So all these mixed questions are going to come. So that's why I'm preparing you for that. A force is acting at an angle. It's like holding a trolley or pulling a bag like this at an angle. The body starts accelerating. The question is, what is the acceleration? That's what we need to find out. So obviously it will accelerate this way because you're pulling it this way. It will go like this. So what are the different forces acting on the body? One is obviously its own weight. Because it is moving that way, friction will act this way and it will be kinetic in nature. Normal from below, it will act like this. And I feel I should resolve this force because the force is at an angle. I'll split it into two components. Forget this F, just resolve it into two components. This will be F cos theta. Do you know why this is cos theta? Cos, pass, close. Cos, pass, close, closer to theta is cos. far away, you commit a sin. So this is basically f sine theta. Everybody? Okay. Now let's see what is the equation I will write in x direction. In x direction, what is the equation I will write? Because it's accelerating, I want to find that. F cos is right, Fk is behind. That's it. The difference of these two is giving this acceleration. So F cos theta will help me. Friction will oppose, will give me mass into acceleration. Therefore, acceleration will be F cos theta minus kinetic friction by mass. Oh, but wait a minute, kinetic friction is nothing but mu k into normal. Oh, but that's a problem. I don't know normal. Guys, what's the value of normal? You will be like, sir, normal is mg. That's where you make a mistake. Normal is not mg. Like, sir, why normal is not mg? See carefully. Normal is there. F sine theta is also there. How is normal equal to mg? So think again, you will understand what mistake you made. If you look in the y direction, this normal up and this F sine theta also upwards is balancing the mg force. Normal and F sine theta is balancing mg. So basically, normal is not mg. It is, take that F sine theta other side. So it is mg minus F sine theta. Do you understand? Yes. Normal is mg minus F sine theta. So guys, my dear students, over here, I'm going to put F cos theta minus mu k. And in the brackets, I'm just going to put mg minus F sine theta. The whole thing divided by m. So this is equal to F cos theta minus mu k mg minus minus plus plus mu k F sine theta. The whole thing divided by m. So that is the value of acceleration. That's it. Values are not given, else I will substitute and find the answer. Sivagami, this is Newton's laws of motion, extension, friction. Depending on which book you are following, it might be a part of the chapter or a separate chapter. In H.C. Verma, it is a separate chapter. Okay? Cool? Understood? Done? Let's see the last question for today. And after that, what am I going to give you? Homework. After that, what are you going to do? If you have missed any part of the lecture, watch it. If you watch the entire lecture, very good. You're going to solve the homework question. And what are you going to do? Post it in the answers. So that will mark your attendance. Okay? Very simple questions I'm going to give you. Come on guys, find the acceleration of this blocks in this particular system. One block on the rough surface. The block is tied via a string to another block which goes over a pulley. This block will accelerate this way. This block will accelerate downwards with the same acceleration. Whatever this guy does, this guy will also do the same thing but in different direction. That's it. This goes down, this goes right. Start with free body diagram. Without that, you are not going to get anything. This block has its own weight m2g. Start with FBD, that's all. This guy will get pulled up by a tension. So if you write the equations of Newton's laws for m2 mass, how will it look like? Observe. Acceleration down, so whatever is down will be positive. So m2g is assisting the acceleration, tension is opposing it, so that is equal to m2 into a. Everybody with me? Cool? Let's go to the next thing. Here, the same string is connected, so the same tension will be there. It won't be different tension. M1 will have its own weight, M1g. There will be a normal from here. And lastly, over here, what will happen, guys? There will be a friction. Why friction? Because there is rough surface. So friction over here. Okay. So in the x direction, what am I going to say? M1 will get pulled by T and opposed by F. In a net result, acceleration is towards the right. So tension minus M1G, why am I saying M1G? Tension minus friction is nothing but M1 into A. Cool? Everybody with me on this? What should be my next step? Think, my job is to find the value of A. What do you think I should do next? Sivagami, whatever lecture you want me next, most likely you should put it up, but I'll do only high weightage topics. Remember, I conducted one small video. I gave you one video, high weightage topics for getting 120 plus marks. What is that video? Choose a topic only from that list and post it in the comments. So when you have two blocks over each other, its mass increases, so normal increases, so Fs max increases. Yes, Sandhya, correct. Yes. Add, very nice. So let's add both of them. So if I add both of them, what will happen, guys? This tension and this tension will cancel. Minus T plus T will cancel. So what will I be left with? M2G minus F is M2A plus M1A. A is common, so I will write it as M1 plus M2 on the right hand side. Over here, it will be M2G, okay? Friction is nothing but mu into N. So therefore, it will be M2G minus mu into normal will be M1G. Normal will be just M1G is equal to A into M1 plus M2. So again, I can take G common. So it will become M2 minus mu M1 is equal to A into M1 plus M2. So therefore, last step, acceleration will be G into M2 minus mu M1. The whole thing divided by M1 plus M2. Correct? That is the final answer. If values are given, you can put it and you will get the answer. Don't have to by heart, but these are just the natural steps. You cannot by heart these steps. It has to come with the flow. It has to come naturally. Don't try to remember anything. It's just drawing free body diagram and then understanding, okay, I have to write equation here, okay, friction is mu n, okay, substitute and solve. That's all. Great. So that's the answer. So please join the Telegram channel so that you get the entire PDF as well as the notes, whatever I have given. This is your first homework question which you're going to solve and put up the answers in the comment section. That's the only way you can mark your attendance over here apart from, posting in the chat box if you're attending live classes. And this is your second homework question. Make sure you solve this also and post it in the comment section. And if you want more additional material, you want live classes for PYQs, etc. and you want test papers, you want mock tests, rank prediction, you want assignments, you want classes for all the topics, in a very systematic, detailed manner. Again, all the Vedantu resources as well. Crash courses are also there. Both the variants, you can check it out. Link is there in the description box below. Make sure you make the best use of it. Okay, so I will be waiting to read all your comments because solving those homework questions is hardly going to take 2 minutes. Let's see who are the top people who are going to fatafat write the answers. And even if you're watching it recorded, it's okay. At least you can put it so that I know, okay, the student has watched the lecture. Okay, guys. So see you, I think tomorrow at, I believe at 5 o'clock or something. Just check it out. I'm not remembering the timing, where I'll be solving questions from Newton's laws as well as friction. Okay, that's it from my side. Have a wonderful evening. Sleep well, work hard. Don't sleep without solving and completing today's task. Whatever task you wanted to do, make sure you complete it. Okay, keep seeing you guys on this channel. Stay tuned by subscribing and show your love by liking. Hasta la vista. This is Captain Shreyas signing off.